in V. If you don't know the types, you can use auto, and the system will know what is there. And notice that here we change the value of elements in the array. Plus I means each element in V is changed and displayed. So we are here. After we go out of the for loop, we are here. And notice that the changes have preserved. Right. If you don't take this, you take the reference out from here. If you take the reference out, what you get with this is these values, but with this one you get again 0, 5 up to 25. So you have to be aware a little bit about this, and this happens in Python as well. So we have seen that SQL provides a hierarchy of iterators, and they are input iterators, out. Which other iterators are there? Bidirectional, forward, random. These are the 5 groups. And then various iterator classes implemented by containers have some characteristics as specified, operators specified by this category. It's a good fact that we can write functions working on iterators, and that they will be applicable to many, many diverse types. So 45 minutes probably. We are not really having too much time. I have put this example on your stream, so you can work with that. And I combine more things. Now, as you can see, type name iterator is here. I can put a different value, just make it shorter. Right, so be aware this is what we choose. And I can put here A and B instead of it and N, but it's helping our understanding. And this is the function computing the min, and then we apply that function to various types. Notice that here we construct a C array and work with a C pointer like you work with iterators. I want to have this here to compare with approach with iterators here and here. So notice they are very similar. Then we construct a vector using pushback. We can construct a vector from this array, but I wanted to practice with methods in vector, and we get the same thing. And then construct a double-ended queue by pushing to front, and construct a list with different values, as you can see. And our templated function, which computes the min, is invoked for these 3 different types. This is an approach which is done by the STL algorithm themselves. Notice that the algorithm is fact that it works on a vector or on a list or of something. The algorithm depends on what operators, iterators provide, nothing else. So algorithms are designed like this, not linked to a container. The only thing you have to know about when you apply this algorithm is what operations the iterator have to provide. Dereferencing, moving to the next, and comparison. You have to be able to compare that you are pointing to the same. So these three operations, which are provided by most iterator, and then you can apply it to different containers. As you can see, we begin with an iterator provided by the vector, the end, the same thing. So this is the first part, and the second part refers to working with input and output iterators, which I talked about last lecture. But if we write it, disable the last part, as you can see, C-type array, C++ vector, they have exactly the same values because we use the same number. And then for the vector, the average sum divided by how many is 0.4, 4.5, which is what you expect. For double-ended QI divided by 10, so you get 0.5. And for the list, I multiply by 10 each element, therefore the average would be 45. But once again, it is a simple example to show you how STL is organized. Algorithms are defined separately, containers separately, and they interact via iterators. What iterators are provided by, what type of operations are provided by iterators in container dictate whether an algorithm works or not on that container. So we stop here, and you can change that and try to very much as there's a question in the exam about standard template library. We spend 3-4 lectures and 2 tutorials on STL. So hopefully you all get some ideas. So tomorrow